Okay, in this video we're going to be looking at the quadratic formula. The quadratic formula is used for solving second-degree polynomial equations, ones that fit this format. The idea is that we take the complete and the square that we've done, which is kind of a lengthy, involved process, and you apply it to this general equation, and in the end, after you go through all that process, you get this result. X is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. This is the quadratic formula. You're going to want to know it. You'll need to know it for your exam. My advice is just to write it down for every problem, and hopefully that'll just kind of start sticking into your head. Basically, it takes solving an equation and turns it into doing an arithmetic problem. Now, the arithmetic problem we are doing involves us having to take a square root at some point. So the stuff that we did in the previous chapter with simplifying square roots still applies here. What we do when we have an equation is first make sure it's in the proper format. Ax squared plus bx plus c, where a is the coefficient for the square term, b is the coefficient for the x term, and c is our number term. So our equation does fit that format, and it's equal to 0. So we can go ahead and recognize what a, b, and c are. A is 2, b is negative 5, and c is negative 3. And then we put those into our formula. So the first thing, it's the negative of whatever b is. So that would be the negative of negative 5, then plus or minus the square root of b squared. Now that's negative 5 squared. That's the quantity negative 5 squared. One of the most common mistakes I will see people make is they'll put negative 5 squared, they'll go in their calculator, do negative 5 squared, right, just exactly what I said, and they'll get an answer of negative 25. And they'll put that in, and that will eventually lead to a wrong answer. It's negative 5 squared, which means negative 5 times negative 5. So if you put it in a calculator, you have to put it in the way I've written it. And then it's minus 4 times a times c. So 4 times 2 times negative 3, and then all over 2 times a. 2 times 2. And now we're just going to start simplifying. So I look inside the radical, and what I typically do is I simplify that, I write that right above the radical, so I don't have to rewrite the whole thing. So negative 5 squared is 25, minus 4 times 2 times negative 3 is 24, 25 plus 24 is 49. So rewriting it now, I have 5, the negative of negative 5 is 5, plus or minus the square root of 49 over 4. Now the square root of 49 is something we can simplify. Anytime we can simplify the radical, we do. So in this case, 5 plus or minus 7 all over 4. You might want to take a moment and try to finish this problem. Think about what those answers would be. Now because we can put those together, we can do 5 plus 7 over 4. We get 12 over 4, which is 3. We can do 5 minus 7 over 4. 5 minus 7 is negative 2. Negative 2 over 4 is a negative 1/2. And so we get our two answers, 3 and negative 1/2. Okay, let's move on to a second example. This equation does not start out in the required format, so we have to have everything on one side equal to 0, so we bring the 1 over by subtracting it from both sides. Now our equation meets the required format, so again we recognize what a, b, and c are in this formula, this problem, and then we plug those into our quadratic formula. Negative b, so the negative of 9, plus or minus the square root of b squared, so 9 squared, minus 4 times a, which is 4, times c, which is negative 1, all over 2 times a. And again, what I like to do is simplify what's inside the square root and kind of write that above. I'd ask you to maybe pause the video and take a moment to see what you can come up with. So when I simplify, I get 9 squared is 81. Negative 4 times negative 1 is a positive 16. 81 and 16 is 97. Now we are going to want to simplify that square root, so we take that square root of 97, but it turns out in the case of the square root of 97, we can't simplify. So since that's it, and you look in the top and bottom, you can't really divide anything out of the top and bottom, we're done. And when you put this into your homework, you'd write your answers down as -9 plus square root of 97 divided by 8, all that over 8, and then -9 minus square root of 97 over 8. But on an exam, you could leave that with a plus or minus. One more example. Here we have x squared plus 2x plus 20 equals 0. It's in the proper format, so we recognize our a, b, and c. A is 1, b is 2, and c is 20. So as I put them in, negative of b, negative 2, plus or minus the square root of b squared, so 2 squared, minus 4 times a, which is 1, times c, which is 20, all that over 2 times a. Again, I like to simplify above, so I get 4 minus 80 equals negative 76, and we set about simplifying square root of negative 76. Well, here we have to use what we talked about with complex numbers, with imaginary numbers. Square root of negative 76 can be rewritten as square root of 76 times square root of negative 1. Then we have that square root of 76 to simplify. Unlike the problem before, we actually can take a square out of 76. 76 is 4 times 19. So we can write that as square root of 4 times square root of 19, and then square root of negative 1, remember that is I. Square root of 4 we can simplify would be 2, and then square root of 19, and then the I. Putting it all together, we have negative 2 plus or minus 2i square root of 19. Typically when you have an I with the square root, we put the I in front. It's okay if you don't, but that's kind of the traditional way of doing it. And then I see that 2 in the bottom and I see the 2's in the top, so oh, I think I can cancel something. So when you see that, then break it up and then simplify each piece. So negative 2 over 2 plus or minus 2i squared root of 19 over 2. In each fraction there, the 2's cancel out. We get negative 1 plus or minus I squared root of 19. So here we actually have complex numbers as our answers. Okay, so hopefully this helps you out as you're dealing with solving problems using the quadratic formula. Until next time.